This afternoon, two of my favorite things. One, Nebulon. Love Nebulon. Two, drinks by the pool. Like that a lot. So we have slides that are intended to guide us, but they are by no means everything we are happy to talk about. So as we go through, you guys know the drill. You'll stop me if you have questions, and they're all welcome. We've had introductions. For those of you who would like a bit more background on Nebulon, we were founded back in late 2018. We have a team of engineers that comprise a fair bit of storage technology, you're probably aware, but also quite a lot of security technology. We've got a fantastic cloud team. So we are much broader than storage, but in many respects, storage really forms the core of what we built. We have begun shipping our SPU and services last year to customers. So we've been in the market for a bit of time now. We'll talk a bit more as we go through it about how we go to market and things like that. But first, I'll give you the Nebulon story, a bit of background there, and kind of our view of the world. Phil is going to give you a breakdown of the news. And Phil has a little surprise for you. Some of this news was out a week or so ago, but we've packed something here for you today that is brand new, and only you guys are getting it. Free to write about it or not, but a little something because you've taken the time to be here. During that time, we'll have some show and tell. You'll get to see the stuff we're talking about. I think that's always cool. And then we'll kind of do a wrap up and go get a drink, okay? All right, so what is our mission in life as a company, as Nebulon? Our true north is really fighting a lot of the infrastructure inefficiencies. As we got into the market, we were getting a ton of feedback from IT leaders and CIOs about their concern about ransomware, malware, and that became a really important part of our focus as we went. We started, really focused on that efficiency bit, but over the last couple of years, that focus on protecting the server infrastructure from ransomware has become central to a lot of the work we do. The principal challenge we hear predominantly from those who've either deployed or investigated in great detail HCI infrastructure, and HCI has done a lot of good in data centers, but in shifting data services off of dedicated devices to your server operating system, it's burning cores. It's burning, in some cases, 25, 30, 35% of your server cores. Who has bets on VMware licensing after the deal closes? Core-based, I bet.
And so
you're paying.
It's shifting to subscription.
Sorry?
It's subscription based on cores.
On cores.
Cores is unsustainable.
I 100% agree. For those who have to write the checks today, though, if you're spending money for software on cores that you actually can't use because you're doing your SDN services, your SDS services, doesn't feel very right. And in general, we talk to a lot of folks who have data centers in place where it costs a fair bit of money. Densification is a theme. Getting full value out of those cores for your VMs and your containers is kind of what they're focused on. At the same time, how we can deliver that and give folks another measure of protection, not intended to replace the fantastic technology that is going on in the network layer, but we're very focused, being down in the server, about doing everything we can there to help CIOs and CISOs get the job done, sleep at night. That's
average installations are concerned that 25% of server CPU lost is 25% of heat generation that you don't have to have.
Yeah, that's a fair question. I probably would just be guessing. The bulk of the conversation we have is around, the impact to the budget of that 25%. But we do, speak to folks who are limited in what their grid's going to provide them, especially folks with a lot of AI projects going. Yeah,
I just wondered whether the
yeah.
small ones, because it's not a question just of not having electricity in the grid,
Yeah.
but your reputation's damaged. If you get highlighted as you're the first responsible for global warming,
Yeah, right. Yeah.
that might not be good for you.
So I will say, on the topic of sustainability, the more brand-oriented companies that are issuing RFPs, more and more that's coming out because it is a brand reputation thing for them, and they're looking to IT to give them some help on the side of the data center.
So IBM says that in comparison with Intel, its chips are far better. It claims that you can only run Intel chips at 75% capacity in any case. So you're now saying that 25% of the 75% has been lost as well.
Yeah, I say, I don't know about the math there, because I say, I can run VMs until my CPUs are tired. And so to me, that's, certainly service providers will run them well above 95% of what they can do, because they get every nickel out of those servers. But there are folks who are only going to run them at that level. But
there are a lot of enterprise software companies that specify an architecture that basically runs at an average of 5 to 10% utilization, because they won't give you a support agreement if they don't have the headroom to burst on a guaranteed bit of bare metal.
Shame on them. Okay, forget the graphic on this slide for a moment. Another point of view we have, and this isn't broadly true for the hyperscalers, but we believe there are a lot of important lessons we can take away from how the hyperscalers have done infrastructure. And it started with at the beginning when we first saw EC2 and S3 in 2006 or 7, that was really the first time we saw in production data services that were not running on dedicated devices, that were running in software in the operating system for the infrastructure at AWS. Since that time, it took 6 or 7 years for that concept to make its way to the enterprise data center. 2011, 2012, Nutanix gave us what effectively became hyper-converged infrastructure. So a great concept, but what's running in Amazon today is difficult to just drop in any data center. We all probably know that. Now, the hyperscalers have not stood still. Efficiency is core to their business, and in 2017, we saw the advent of what I'll call a DPU-based server, but Nitro-based servers in AWS. Great for efficiency because they've unloaded the storage and network weight on those server CPUs, and they want to sell all of those server CPUs to you and I. If you dig hard on the internet, you could see Microsoft Azure kind of talk very candidly about what they leave on the table for lack of that approach for many years. So that is a important aspect of efficiency for those data centers. And again, we think 6 or 7 years later, we're in 2023, now is the time where that should start being broadly applicable to the enterprise. We believe with the technology we deliver, we should be one of the important considerations for getting there for customers. If you want the efficiency and security that the hyperscalers, in AWS's case, have been doing for years, think about what we're doing. This graphic really just, in simple terms, says, look, for a long time we've been running infrastructure services in the operating system, on the server cores. We're talking about moving all of that to ARM-based cores that run with less heat and are more cost-effective. One thing we do try to express to our customers is when you are implementing this DPU-based infrastructure, am I adding something? We get that question a lot. Am I adding something to my server? And if so, what? And in a lot of ways, they're trying to figure out who in their team needs to look at this. And the answer is no. We are replacing something in your infrastructure. We are replacing your storage card, your network card. We're actually eliminating your need for boot drives in your servers, and we're actually reducing the number of servers you'll deploy. The SPU, the DPU running our software, is going to handle all of those functions and eliminate those things from your hyper-converged configuration. So there is going to be a densification of your environment moving to DPU-based infrastructure.
Being stupid, what does DPU stand for?
Data processing unit.
Right.
Yeah.
Whereas Intel calls it an IPU.
Everything?
Oh, CPUs are data processing units, aren't they?
Yeah, you can argue with Jensen Huang at NVIDIA for how he's coined the term, but the reality is the DPU is intended to be a PCIe-based card with big processing and memory assets on it to do a wide range of things. Mostly network we see today. We see some accelerated storage cards in the market today.
So they're specialized. The same way as a GPU is specified
Correct.
for calculations.
Yeah.
DPU is specified
Right.
for moving data around.
Right. We think of the world as we have CPUs, of course. We have GPUs that kind of went the way of, a video card and then gaming and now AI and very smart. We've seen that with DPUs. We've seen NICs and smart NICs, and now we see DPUs with a whole lot of firewall function and stuff like that on them. We see now in storage and the security side that same progression. So yeah, continuing to offload those things from
So what you're saying
the
is in the
CPU.
future, server is a hybrid box containing specialized group architectures for various functions. And it might be a lot more for the CPU. There might be a specialized card for processing AI type loads, a specialized one for doing DPU, a specialized one for running a network.
Right. Yeah. I see the server is the thing running the app, right? But it needs a lot of help to get the app work done. Storage,
They don't need
GPU,
to share
yeah.
the same CPUs.
Right. That's
Yeah.
right.
It's effectively infrastructure services
DPUs
abstraction.
be used in theory to build more efficient hyper-converged systems?
100%. There's an issue though with DPUs in the market today. We think we're solving a portion of it. DPUs let's back up. GPUs today, if you talk to your NVIDIA salesperson, they don't talk so much about all the stuff on the GPU. They talk about the software and the libraries and all of that stuff you get to build your environment. DPUs, that conversation doesn't happen so much because there isn't a rich software environment on top of most DPUs. There are underlying APIs, but unless you have a bench of PhDs, you can't do so much with it. So the promise of that efficiency that DPUs bring can leave folks a bit short if that software stack isn't there for them to plug and play and take advantage.
So what software stacks do you currently support? Azure Stack, VMware Cloud Foundation, Google Distributed Cloud?
We are an on-premise enterprise solution. So we're supporting all of the operating system hypervisor stacks, virtualized, containerized, bare metal that you're deploying in your data center today. we don't have any kind of dependency on the operating system.
But do you have, say, a productized stack that you can sell with Azure Stack HCI to
Nope.
run on a Dell box to do
No,
this?
our customers generally already have that. They just want it to be able to run on their next server buy. And so for the most part, every customer we talk to has a purpose-built, entirely certified, RHEL, Windows, VMware stack, and they're looking to bring greater efficiency to that environment. That's what we do.
Do you see that being a restriction on your market potential out into the future?
The opposite entirely, because when someone has software that they're married to, getting them to change that software is tough, right? It's different if you're going to a cloud service provider, because you're now entrusting what they do and their services for what you're doing. But when you're responsible for it in your data center and you've developed a stack over the past 5 years, 10 years, 20 years, why wouldn't you want them to be able to run exactly that on their server infrastructure, right? That's exactly what they want to do. Why not enable that? Not everyone can do that, but we think that's an important reason to get DPU-based infrastructure happening in the enterprise. Otherwise, if the enterprise has to change their software stack, I think a lot of them would change it to a public cloud stack, right? So,
Which is what's happening.
Yeah.
Again,
that's
so
right.
my view is, ideally you should have effectively verticalized support for each of those main private public cloud stacks that are being deployed in private IT as part of your go-to-market. You may have a whole different business around other areas, but if you're not supporting particularly Azure Stack HCI, you're missing a trick, because a lot of the market is shifting to that with the current version.
Yeah, and we have had conversations around that. Again, the software qual for us is minimal. We would do. We intend to support everything folks are running. Yeah, not our place to change it. There's an interesting dynamic in our business that I did not predict. So there's still obviously a ton of three-tier infrastructure out there doing the job it was sold to do. We've talked to folks. I expected our customers would be predominantly HCI customers. If you want to know who we think we compete with, we think we replace HCI-based infrastructure. However, we've spoken to a number of enterprises who, three-tier based, they run lean and mean shop. For them, bringing HCI in bloated the server infrastructure to such a degree that they said, no ROI there, we're not moving. And so what we found is, I would say a fair percentage of our customers, probably more than half, actually have looked at HCI, but we're not replacing HCI because they didn't adopt it. They're going from a three-tier environment to a server-based environment, basically skipping over HCI.
How many of those customers are very heavily automated and orchestrated?
I would say to a certain degree, pretty heavily. They don't, we've seen some of the automation they've had to do in the three-tier environment, nesting in their automation scripts because they're doing it by SAN. But it's, for them, it's all about the dollars and cents of the infrastructure, and they continue to do that.
When we see HCI going in, you're heavily orchestrated.
Yeah.
You have a dynamic environment, whereas a lot of companies have static automation, which is stripped to deployment and leave it. And you won't find this attractive to that part of the market. But if you look at the orchestrated side, you will.
And to your point, I would say our most interesting and largest opportunities are heavily investing in that direction. We have one customer who's, I would say, 90% VMware, and they are pivoting very aggressively to Linux, containers, automation. I mean, they have a big job ahead of them, but that is really, so exactly your point. I don't need to say too much more on this slide, but from that three-tier
Just
perspective.
one thing there.
Yeah,
So one
please.
SPU. Do you think companies are comfortable with one SPU per box,
Yeah.
or would they be looking for two?
So we have this conversation a lot. An SPU, when we get into it, it might be the next slide. It is. So I'll explain it here. When you plug in,
before you get there,
yes,
you talked a lot about HCI, the changes and so forth. Are you also observing a change as now that COVID's over and there is a movement towards stated repatriation? Is this helping your cause, and are you seeing a reality of that repatriation?
We have a couple of customers who are repatriating. I would say for us, I don't see it broadly, but where we find it, we have common vocabulary because we're talking about fleet-wide automation and cloud-based control. So that's like great for us.
Yeah.
We need to have a nice big event in Barcelona that's the repatriation event, so I can find all these people, because part of it is finding those who are doing that. And we found a couple, but I don't know whether it's a large percentage or not, but it's a minority of our.
So it's not driving any, significant or noticeable business.
We have one of our largest financial opportunities repatriating. So from that perspective, we're seeing.
Fair enough.
Yeah.
Thanks.
Now, in answer to someone's question.
The multi-SPU?
Oh, yes. Yeah. So an SPU goes into the server. The SPU connects, you can't see it really in this marketing drawing, but it connects to the disks in the server. If you run, and so you'll run a small cluster, we show 3 servers here, and those SPUs will communicate with each other, share storage, and if you lose an SPU, the other SPUs will pick up for that. So the loss of an SPU is handled by any other SPU in the cluster. You could put 2 in a server. You would split the disks in that server across the 2 and make a smaller, kind of failure zone. Sure. Most of our customers don't do that, but they love knowing that they can do that. I was telling someone last night, Chris Evans, one of our customers is configuring servers with 24 32 terabyte drives. Great candidate to split that across 2 SPUs and shrink your crater if something bad happens.
But can you not run them at least active standby and switch over, that type of thing?
All SPUs in a cluster are by default doing that with all
on
SPUs.
one box, so you don't lose that pool of disks?
You do it across the entire cluster. Any SPU in the cluster lose and its drives now unavailable. All the other SPUs are picking up the volumes that have been mirrored to those various owners. They can be
You're
within.
still losing a fair amount of capacity and performance when that failure happens. It's not a no impact failure.
Oh, no failure is, as far as I know. So I think you would, if you lost an SPU inside of a server, your point is you keep the server.
Yeah.
Yeah, and for those who it's important enough to do that, they do. For some reason, most people configure with a single SPU attached to those drives. But the availability model is the same. All SPUs in a cluster, whether bunched up in one server or spread out amongst many, protect each other. What is a Nebulon system? A Nebulon system, we're really just a component for the server. We have the SPU. We've talked a bit about that, and you're going to get to kick around our latest. There is a construct we call secure enclave, a kind of a secure zone. Think of it as like a panic room in the server. that contains the SPU anchors that enclave. It contains the SPUs, it contains all the data services, the boot volume, the data volumes, the snapshots, all are part of this secure zone in the server. And this zone is separate entirely from the application domain, the OS, the cluster software, the applications. So if something bad happens on the app domain side, the infrastructure side is still available. By the way, because management, the control plane is done in the cloud, off-site, if the worst happens, the cloud can contact the SPU and reinstantiate that server by rolling back to a time before a ransomware attack happened, let's say.
So for that cloud management plane, do you get your customers asking for a appliance they can install in their private IT rather than having to run public cloud?
And Phil will talk a bit about how we handle that conversation. Today, we're talking with clients who are comfortable with that and comfortable with our security approach there. But we have especially certain government entities would like that kind of cloud on-prem. That's not something we're doing soon, but we get that request. Yes?
What's the difference or the similarity between your secure enclave and the trust computing?
I don't know if I can answer that question.
Yeah, so our card is more of an infrastructure type play. So what we're doing here is we are replacing a storage element, replacing network element, replacing boot element, and making a secure way of managing that core infrastructure. So getting the operating system booted up from that point of view. So we're complementary to that. We don't replace it at all. We are essentially downloading, installing a boot image, and then handing that boot to the server to then boot up through its normal process. Okay?
That makes sense. Great.
So there's no obvious way to attack the SPU itself?
Can you repeat the question, please?
Yeah, so the question is there no obvious way to attack the SPU itself? The SPU that doesn't present any way for malware to execute. So, in that regard, it precludes that. No network access behind the SPU. Okay.
But just like anything in IT, there will likely be ways to compromise it.
Yeah.
And
Yeah, that's
It's
right.
really a popular problem because the easier way to compromise it most things.
We get the question a lot because we are a component in the server, and some of us came from a storage company, and we were the infrastructure, and we talk about that. We have to be careful here because we're really just a part of this server-based infrastructure, and so when it comes to buying this, we're happy to show up in front of a customer and talk about the benefits within their server infrastructure. But for a customer, if they decide they want to move ahead, they're getting quotes and fulfillment from their strategic server provider, whether they're buying directly from the companies I show on the screen or a channel partner who is providing that service for them. Those are the folks who are quoting, taking the order, and delivering it. And that way, when the server shows up in the rack, it comes with everything they need. They switch on power, connect to a network, registers in the cloud, becomes part of their composable server infrastructure.
The guarantee still applies insofar as it gives you a guarantee.
Sorry?
The warranty still applies insofar
Of course.
as it gives you a warranty.
Yeah, for sure. Yeah, and we do. So that's effectively how it goes. So we built relationships with all of these guys, and yeah.
So do you have a post-delivery business model of go-to-market rather than integrated point purchase?
What do you mean post-delivery?
So if someone wants to upgrade an existing server with your system?
So generally speaking, we found a lot of folks don't want to do that until they do. And if they do, it's usually, we had one customer who bought a load of stuff, but then they just last year bought a bunch of servers that they wanted to kind of upgrade. So in that case, we will sell brownfield, and we'll work typically with a channel partner to get those servers updated.
So you can buy individual SPUs and
yeah,
install
yeah.
them and get them running.
It's and it requires a bit more orchestration behind the scenes, but you know, you can kind of get why people want to do that. A lot of folks generally, we're dealing with, you know, large new projects, and so we're coming in at the beginning of a project and it's not an issue. But for those, we did kind of blanket data center replace, and that was the customer who wanted everything.
Again, that's been one of the reasons of slow DPU uptake overall, has been the requirement that it's often been only in new build servers rather than being able to retrofit.
Yeah.
And therefore it's useless until at least 50% of your server base has it.
Oh, and our channel partners love the business of the brownfield upgrades. They really do. So it's cool. Okay. Now, enough of the Nebulon story, and hope you get a good sense for who and what we are. The big news that we're announcing is the new, we call it the Medusa 2 SPU. It is the first DPU to bring storage, network, and security capabilities onto a single DPU. The capabilities of which Phil will get into, but I have to tell you, when we talk to customers about one thing that brings it all together, it's the interest is off the charts. And so, yeah, we're very excited about it. So Phil will kind of walk you through what all it's capable of. And with that, I think I'll turn it over to him to unpack that, okay?
Cool, thanks Craig. Right. So we'll just build a little bit about NebOS. NebOS is basically our software stack that runs on our services processing unit. Okay, so that's our software stack. That's a whole lot of functionality that Craig's kind of been alluding to, and we're just going to build through those pieces. The first of all is it does enterprise data services. You won't be surprised, you know, a lot of IBD's background is from 3PAR, so it's pretty feature-rich in terms of respect for what we do from that side of thing. Dedupe, compression, razor coding, mirroring, snapshots, etc., encryption, and so on. So all those core storage functionalities in there. And that's originally how the product launched, sort of 12, 18 months ago, was primarily as a storage type platform. Okay, so feature-rich in that area. The new card adds NVMe over fabrics, so we now talk native NVMe to the host, as opposed to the previous card would talk SAS SATA to the host. So it would appear like a SAS RAID card. The new one appears like, unsurprisingly, a blue-filled NVMe snap card from that point of view. Okay, so pretty rich in that sort of areas. I'm skipping that one because it's pretty boring. It's storage, and we do all the same stuff as everyone else. Got any questions, by all means, grab me a bit later on. In my view, they go up in terms of interest. In terms of server OS integration, so we are an on-prem solution, okay, and we are agnostic. So all the functionality we have, every piece of software we talk about, whether it's networking, whether it's cybersecurity or storage, runs on this card. We do not install anything at all on the host. That way, we don't really care what the host stack is. We're just presenting up a raw block storage device to it, or multiple of those, okay? So we don't care if it's Linux, bare metal, Windows, VMware, or anything.
Do you make use of any of the installed hardware on the host machine, or is everything, all the hardware you use, purely your own SPU?
So the only components we use in the server are the SSDs. And those SSDs are physically connected to our card. Okay, then all our software runs on this. We don't touch anything else inside the server.
So those SSDs actually installed on the card itself?
Physically, no. So if you take a standard server, it's got a bunch of SSDs in the front. They're normally cabled onto the motherboard or a RAID card. That RAID card doesn't exist anymore. That cable is plugged into us. And you'll see the card come out a bit later on.
So you have a massive PCI Express NVMe set of control ports?
We have a 16 ports in the back of the card.
So if you have an EPIC server, and one of the advantages of EPIC, it's 128 lanes of PCI Express. A lot of companies are putting their storage through that. You can't use that anymore. You've got to go through your card.
You put it through our card, yes. Okay. We're essentially replacing the RAID and storage element completely in those servers.
Okay. But of course, they can still connect disks to that CPU.
They can do their own, but then outside of what we control.
Services, yours would be SPU side services.
Yes. So if you want to do something in the server itself, You can do. For example, 90+% of our customers use us as a boot device. But if a customer wanted to put an M2 drive in the server, they could. I think it's a silly idea because we can do that in a much better way, but you can still do that. The card itself has high-speed networking ports, so you could go off and connect to an external storage array if you wanted to via our card. Nothing to do with us, but we will facilitate that if you should so wish. Okay, so we have all the integration with VMware, and we have Kubernetes drivers, CSI drivers, etc., around this sort of world. Then we move into how we manage the platform. So we are a cloud control plane. So you never log in to the SPU. You never connect to it. It has no ability to connect to it at all. There is no login. There's no access to that SPU. It's a physical card in that server that you do not know exists or touch or can do anything to it. You can't run any software on it. You can't load a driver and tell it to do anything. Okay? It only communicates with our cloud platform. And we'll talk about in the security in the next slide how that works. Okay? So it's all centralized done from that point of view. This allows us to do some really clever things. Okay, so we talk about customer buys 10 servers from one of the OEM suppliers or our channel partner, and they turn up on site. They turn up and all their servers do nothing. Customer then has to get into their automation platform, Pixie boot, build them all up. The other approach is they turn on, they connect to our cloud platform and say, hi, I'm ready, what do you want me to do? They click a button or run a single script, and that card will say, right, I know what to do now. I need to go down, pull down this boot OS image. I need to install it on all these servers. I need to configure all the storage and turn them all on. That entire process takes less than 5 minutes, depending on the size of that download, but it's about a 5-minute process with either one click or one API command to have all your servers up and running. Okay, it's a parallel task, so I can do 5, 10, or 100 in less than 5 minutes by clicking a button. Or centrally managed. Really powerful when you start talking about edge customers, fleet management, lots of sites from that side of things. We also do all the updates to our card firmware. We can do firmware on SSDs, firmware on SaaS backplanes, things like that. We can obviously do OS upgrades as well from our point of view. When you start talking about edge locations, so if you think about how most customers that have done edge, they either do edge with 2 small spec servers and a tiny storage array, or they do an HCI type platform. We can do edge with just 2 servers, 2 SPUs, and just a couple of disks from that point of view. Our cloud platform acts automatically as a quorum witness. So if you buy 2 servers with 2 SPUs, you just manage it and it works like normal. If you bought 10, you wouldn't know the difference. But in the case of when you have 2, our cloud platform joins the cluster and acts as a witness. It doesn't run compute or storage, it's just part of the cluster. So if one server goes offline, the cloud platform says, hey, you're remaining, take over and carry on running again. So people don't have to decide, do I want 2 nodes with some extra thing to manage, or do I want 3? The answer is it's identical to us. Okay, and you can even directly connect our cards together for those customers who don't even want networking on site from that side of things.
So if you get your firmware update wrong, or you make a mistake in your coding,
yep.
Is this then a single point of failure for the whole cluster, or for just one CPU, or do you ever, is it possible for you to make mistakes?
Everything's possible, so let's be clear about that. It's never happened, but everything is possible.
Yeah.
I mean, so we thought about that just in case. So the card has a pre-built locked-away image that it will default to if there's any issues. So it comes back up in a very basic mode, and all that does is connect up and will then re-download something new and start again. Okay. There is also, for those very unusual customers, there's even a little pin on the back that will factory reset it, and then it'll go on the cloud and download and start again. Okay, so we've never had to use those, but they are possible just in case.
And do you say keep the previous state to do a rollback if there
Yes.
is an issue?
Yes, and we can start to do, one of the features as well, we can start to do that with OSs as well, multiple boot volumes for the server as well. So if something outside of our controller has an issue, we can roll that back as well. Security I'll talk about separately. And then probably the most interesting, architecturally we are very different to everything else out there. And this is what the hardest thing to understand. When you compare us with HCI, the HCI software can do similar things to us. Oh, look, they've got snapshots, they've got dedupe, they've got encryption, blah, blah. It looks the same on a PowerPoint slide. Architecturally, very different. Ours is running on a physical card locked away inside that server. Craig calls it the secure enclave. It's a completely isolated security domain from everything else. Those HCI platforms are running on the server. So if that server gets compromised, so does that HCI type software. Okay, ours doesn't. Ours is completely separate. So if the server is under attack or having some horrible condition, or even if it's had some kind of hardware fault, we're still running and don't care, which allows us to do some really, really clever things around cybersecurity. I'm going to talk about those in a bit of detail about all the ways we handle and detect that.
Like the mainframe too, isn't it? Basically out of band management, isn't it?
So, I mean, I did work at Hitachi Data Systems a long time ago, but not in the mainframe division, so I'll take your word for that one.
Yeah, but clearly what mainframes, you've got address space that can stick up and stick out.
And this is isolated. It's like it's a lot of, like iPhones do it, for example. They have an isolated section. It's a secure enclave. We do the same process. It's not a new way of doing stuff. It's a very well-known industry best practice way of doing stuff. It's just you can't do it on a normal server because it's one domain. Yeah. And that's by nature of the way they work. So this is a bit of an eye chart, but you don't need to see it, so don't worry, I'll explain how we do. So security was fundamental to the design of this card. Okay, we were in a world where security was becoming much more important. Okay, so we had to think about that approach. We decided we were going to be a cloud-based management platform only, so we don't have something local managing it and then layering on a cloud platform. So we had to think security is very different in the first place. So the card itself is built around security from the start. So on the physical card, there is a cryptographic code processor on that card. Okay, so this is a physical chip on the card that comes from the security industry, and it's where we store the keys. Okay, so it's a hardware-based key storage chip. Okay, it allows us to put a key on that chip, and nobody can ever read that key back. Okay, it's the same thing that's used in security products you buy elsewhere. Okay, it's just physically on this card so we can lock down and know that key is secure. So you can't possibly get that key. We can't get the key. The people who make the chip can't get the key. Okay, so a way of storing keys from that point of view. The card itself has signed firmware it runs at the low level and signed software, the NebOS software. It'll only secure boot and download that with a whole lot of security encryption to make sure it's got the right images. And no one can log into it and do stuff. There's no SSH or connectivity to it. Okay, so it's a completely locked down, secure environment. Our cloud platform has a whole load of security as well, so role-based authentication. We have two-person commit, so you can put the groups or environments into two people, so the customer has to have two-person approval to make any significant changes for those production environments. So we can do all that type of stuff as well from that side of things. But fundamentally, we talk about this security triangle, and this is key to how we do things. So we have the infrastructure, so these are the physical servers on the customer site with their SPU inside it. That SPU has a management port on the back, a network port on the back of the card. Okay? Now, we would expect the customer to have that port is only accessible locally. So obviously it's not presented to the internet. Okay, it's local access only. Okay? So it's local access only. You can only connect to it if you're physically on-prem or you have a VPN of some kind. You have our cloud platform running in the hyperscalers outside of this, and then you have the API client, or in my case, me with my laptop sitting at home. Okay? So the way this works, I'm sitting in my web browser and I want to make a change. I log in to the cloud platform, I use the Nebulon security, multi-factor authentication, Active Directory, role-based, and so on. That says, yes, you're valid to issue that command. It sends a token back to me, to my web browser. My web browser forwards that directly to the card. So this is under the customer's security model. So is that physical? You're physically in the data center. Do you have a VPN access? Okay, so now the customer can control this. Once that information gets to the SPU then goes back to the cloud and says, checks, this is all expected. Or this is all encrypted, all time-stamped to make sure that that was expected, then it gets executed. So this means that if somebody is able to log into the cloud, so I gave someone my password on my phone and they logged into multi-factor authentication, they can still do nothing because they're not physically in the data center or have the customer's VPN. If the customer's on-prem has been compromised, they still can't do anything because it needs to go back. So it relies on Nebulon and the customer security both being in sync at the same time, two completely isolated security systems.
Excuse me, just if some malicious actor has access to the browser on the target and managed to get its hands on the token, then he can do whatever he wants.
No, so that token is specific to the operation you've requested to do. So I've said here, I've logged in, said I want to do something, delete a volume, say something bad. I want to delete this volume, assuming there's no two-person commit, so I have approval to do that. It goes up there, Nebulon validates that, says, right, you're allowed to do that. The token comes back, the token gets sent to him, he checks back, it gets executed. Okay? That entire process has to happen within a very short period of time.
So it's specific to an action. It's
Specific
not
to
a session call.
that command, individual command, and time-stamped. So if you held it and waited and sent it a few seconds later, it would be invalid.
Okay, it's not valid for the full session.
Correct.
And it's all encrypted as well. They wouldn't have the keys to send that. Even if you got that token, you wouldn't know the keys and encryption method to talk to the SPU either. Okay, and then it goes back and validates it. So this is the incredibly secure mechanism we have around making sure that we do everything possible, to your point earlier on, to stop anyone attacking it.
Taking it 1 point further, can you, if you've just been sacked, you're the CTO, you've just been sacked, can you do something in this system which leaves it locked up in such a way that nobody can unlock it without being very nice to me? So I can hold you to...
Not normally, because
It's a bit like San Francisco.
So in most environments, it would be a two-person commit for secure environments. So you need two individual people to do something, and it goes through an approval process for anything disruptive.
So you're assuming they've got proper trusted operator.
Yeah, if they want to have one person that can do everything, then that is allowed, because people have test dev and less security, and they're allowed to do it.
But it was a threat then of internal sabotage. Yes.
And that's why two-person commit is something that people would recommend from that side of things.
Just two more things. First of all, where's your bounty program for your API? And second,
There isn't one. Okay, next person.
and second, where's your audit of your internal software supply chain processes? Where is it? Where are the audit results? Because I mean, I love when someone says protected software supply chain and tells that, oh, we're talking about trusted sign OS firmware that is send OTA. That's wonderful, but it's not as if we haven't seen quite some high-level cases where the software supply chain was successfully compromised and to spread wonderfully trusted and signed pieces of software.
Okay, so the question's all about supply.
And I remember questioning a storage vendor about his actual security of his DevOps after he had been compromised with ransomware himself.
Yeah. Okay, so the question's about, I'm talking about we run secure software. How do we ensure Nebulon that the software we supply is correct and not compromised before it gets in this mechanism? So clearly within our organisation, we have a process that has to go through. It is quite a complicated process. I'm not involved in it. I don't have access to it. But it requires multiple people to sign off on to use certain keys to release software to the chain. So it's not something that one person could do in our organisation. Okay, so it has to go through a strict change of control, strict analysis through a security team, and then multiple people sign that off with keys to permit it to go out. And then there's a full audit log internally about that process. Okay, I don't have all the low-level details on it, but if you want to talk to our security guy, you can. But it's not as if individual engineers or small groups of people are permitted to click buttons and roll stuff out from that side of things.
I would find it, I would just at least fancy as a potential customer to be able to have access to the results of
the audit.
External independent audit.
Yeah, we have audit logs, yes.
Yeah.
We do have full audit logs, and we have security reviews internally with external companies. I can't remember the name of the one who did it last, but we can share that. I don't know off the top of my head.
I'm sure we don't. Yeah.
Yeah, I mean, it's not sufficient for it.
It does help us with that, I agree. Okay, so let's talk a little bit about some of the cybersecurity advanced functionality we have. So if you think about cybersecurity, we're talking about how can we protect your environment in the first place to reduce the chance of an attack being successful. Now, statistically, nearly every company is going to get attacked at some point in a few years, but everything we can do to reduce the chance of that happening. And we have some functionality we call immutable boot and some other things around that.
If I may, I really like this one.
You like this one?
I really like this one because I find it extremely funny. There are a few pieces of ransomware, like one that's currently outside right now that's called No Escape. which has the specificity of rebooting the machine after the beginning of the compromise, before starting the encryption process. It makes the analysis of the ransomware more difficult and more complicated for malware analysts, because you need to have a sandbox that will support reboot, to be able to have access to the actual software and how it runs, etc. But for that kind of software, for something like that, that's fine.
Yeah, so this is exactly where this comes from. So there's a few things we do about reducing the chance of security in the first place. Some of that is the fact we can help you deploy hardened images in the first place with centralized management, with secure, all the stuff we talked about to ensure that every server is built in a predetermined way, best practices. But the key piece of software we have is something we refer to as immutable boot. So this is when you set that server up, either via our automation process or the customer uses their own one because they prefer it for whatever reason. Once that server's up and running, okay, so day one, it's booted, it's configured, that server's ready for production, we take a copy of the OS image. Now, the thing that's unique about us is we are providing the boot volume to every single server, whereas most storage type solutions do not present the boot volume, they present data, the shared volumes, not the boot volumes. Boot volumes are normally on a couple of M2 drives. We are presenting the boot volume, so we take a clean copy of that from day one, okay? Every time you reboot that server, because we're a card inside that server, we know the server's been rebooted. The server reboots, we say, hey, server's rebooting, we delete the current boot volume and put the old one back again. So Groundhog Day. Okay, so if I install my server on a Monday, I reboot it on a Tuesday, we roll that server back to a Monday. Okay, so this is for customers that don't store data on their boot volume, which is best practice. Okay, so a simple reboot of that server wipes out anything that's happened since that first day. So any malware that's hidden on that server, malware typically stays for weeks or months, hidden on the boot volume, gets erased anyway. So you may never even know you were infected, it's got wiped away.
That does rather assume that your internal security procedures are excellent, that you have human resource procedures, that you won't employ people that just sacked, stuff like that. So your security becomes part of my security.
Right.
Because if it's a targeted attack, the way in is to get an employee at your company to do something, put something onto that boot drive on day one.
Yeah, and that's that's really all we can do from our side of things. We assume that the customer has done that day one image, they pre-built it through some process way, we ensure we roll back to that. If that's already infected, then customer's got no hope, realistically. I think it's a fair example. So we roll that back from that point of view. The second thing we talk about is something referred to tripline. So we are essentially, when you get down to nuts and bolts, an I/O card in the process, doing every single read and write I/O goes through our card. So we can, in real time, analyze all reads and writes. So we can start to detect ransomware attacks in real time. Now, we are complementary to all other detection software. So we're not saying, don't buy that network intrusion software, don't deploy those agents on the host. We are complementary. Okay, so you already have software that detects for network attacks. You have software that's looking for certain processes and I/O stuff going on the host. We are looking for low-level block I/O patterns that are unusual behavior. So every 30 seconds, we take a signature of how that volume is behaving on a per volume basis, and it goes to our cloud platform, so no data, just I/O stats. We analyze it using machine learning and look for unusual behavior. Has it changed? Is the I/O pattern differently? An extreme example being, this volume's been running at a relatively normal I/O rate, suddenly it's doing high encrypted writes. I mean, that's obviously ransomware, it's happening. Okay?
Phil, yes, it sounds like you have a lot of automated, functionalities. Do you use any AI help, and to what extent AI is impacting your DevSecOps teams?
Yeah, so the way in all of these, the one process we use AI is app detection. So our cloud platform has AI, machine learning, and it's working out how this particular customer, this particular volume on that particular server normally behaves. So we're using machine learning to analyze that on every 30 seconds, so we can now say, we know how that volume behaves. Over time, we've learned it. So now we know when it deviates. So every 30 seconds, it's deviated slightly. And once we've seen 5 consistent deviations, so this is its normal I/O path, it's doing this, so 2.5 minutes later, so 5 consistent deviations, we will flag that to the customer as a possible ransomware attack. We're seeing unusual behavior. We plot up some pretty pictures with colour saying this is where time it started deviating, this volume, this host, you need to go and look at it, and then tell us, no, it was nothing, I'm doing something else, or yes, it's a ransomware attack. So we can then learn from that as well going forward.
Will you share that information with the rest of the industry?
We don't at this stage.
It seems that one of the issues about security is that people don't share, so the same attack will work on multiple sites. Because
So it's a difference. We're doing this at a much lower block level. So we're looking at I/O patterns and how they behave.
So
so some of it's very specific to a specific customer, but some is more generic. The reality is the generic stuff, unless those other customers or other companies can detect and analyze what we do, there's not a lot of use to them. So if I gave that information to a networking guy, no use, because he doesn't see block level I/O. Only RAID cards would see that, and none of them.
If you knew where this was coming from, which presumably the person switching off the ransomware attack would, you could then share the fact that the person is coming from, we've been attacked by so and so, we stopped it. You should be aware that this particular IP address or something is doing something.
So we're below that. We're just saying we're seeing an attack on this volume. Then the customer then uses other software to work out how to. We're saying we know there's an attack happening here, but we don't know who or why.
To your point though, downstream, there's some really convenient integrations we could do with higher level security software that would inform the customer through that, Palo Alto, CloudStrike, whatever. Those integrations aren't in place today. We do what we do, but it's something we've talked a lot about internally, something we'd like to get to.
Because it seems to be one of the big issues that most people not sharing data about attacks.
Right.
And if you detect an attack, do you, for example, clone the blocks that are being altered?
I like you. So the next one is time jump. So we are trying to stop it in the first place. We're detecting it's happening, and then this is about, okay, I've been attacked, what do I do? So this is about recovery. Okay, so when attack has happened, what do I do about this? So again, uniquely, we are providing all the shared data stores and all the boot volumes. So if you think about a normal environment, I've got maybe 10 servers in the cluster, they've got 10 separate boot volumes, and then maybe 5 shared volumes. We control all of those, okay, which is unusual. So we can take cluster-wide snapshots. So I can take a snapshot of every boot volume at the same time, every shared data store at the same time. So I can roll that entire cluster back in time. Okay, so an attack has happened. The trip line has detected it, and you've specified I want a recovery point every hour, for example. So what happens is, this detects it, pops up saying, this has happened, do you want to roll back? And you click that one button. Let's say my entire cluster is compromised. Worst case scenario, all 10 hosts are all offline, everything's compromised, the world has ended. I need to recover my entire cluster. Everything is gone, it's a catastrophic worst case event. You click that single button, our card will take a brand new snapshot right now of the entire environment. You're going to need that for insurance reasons, so that's a forensic snapshot of the current hacked, compromised state.
Far away. Check the insurance companies accept this delivery.
Well, they take the data, so they're happy with the data. This is the data. So we take that copy away. We then shut the servers down, so we physically power the servers down, we roll back all the data, we turn all the servers back on again. That entire process is less than 5 minutes, and the servers are back up in time, and they roll back half an hour, whatever period of time, and they're back up and running.
I mean, this does honestly sound very good. So you could get a marketing advantage by offering a guarantee against the ransomware attack.
He's the man.
I like the way you think.
And you can get reduced insurance rates.
That's even better, isn't it?
Yes.
Sorry.
How do you ensure that the snapshot was not corrupted?
Corrupted in terms of being in use when it happened, corrupted as in terms of it was compromised or attacked.
Yeah, but when a ransomware attack, most of the time, even if this line is very efficient, it could be that the data were already encrypted for a part or totally.
Okay.
And your snapshot, how do you ensure that in fact you're not introducing the new enemy?
Got it. Okay, so the question is about how do we ensure our snapshot is correct and safe and permissible to go back to. So first of all, when you click this button and you go back, let's say an hour, let's just use an hour as an example. If you got it wrong, you can say, no, stop again, go back 2 hours, go back 3 hours. So I can roll through that process multiple times. It's not a one-click button. You can also click it and say, actually wasn't a ransomware attack, whoops, go back to where it was. So these are completely options. I can go back and forth until I'm comfortable to that particular process. Second thing is...
So the person who's looking after security needs to be well trained, because if they panic, I can see them doing this wrong, or...
Yeah, but normally, they're not. You shouldn't. One, there's again 2-person commit, but again, you wouldn't be running back unless the entire class is offline anyway.
It's not your problem. It's just
it's
back of my mind. It's
best process, best practice.
People don't actually test their ransomware recovery processes, and they have them, but until I actually test them and do a few dry runs, they can't be confident.
This makes it easy because a dry run is 5 minutes. Click a button, down it goes, up it comes.
Yes, it does.
Okay. So we can roll back to different points to find one if there was an issue. The second thing is the vast majority of ransomware and catastrophic offence is attacking the boot volume. And when we click this recover, going back half an hour, we're shutting down the data stores, the shared volumes by half an hour, but the boot volume is going back days or weeks. Okay? So it goes right back in time to when we knew it was safe to when that server was either installed or patched or upgraded. So that's how we can ensure that the ransomware attack might happen at 9 o'clock this morning, but I was probably infected a week ago. So that's why the boot volume goes back a long time, but the data volumes go back just before the attack.
I think the operator, I say it's not your problem.
You're always at the mercy of the operators.
Yeah, well, it needs to actually know about how far back they might have to go. And realise they might have to take the volume back a long way further than just the attack.
Honestly, to put it in terms of better, if you have someone who uses that and considers, I've got a ransomware, and I'm just rolling back, and I'm good to go. It's just stupid. Fire it. End of the story.
It's too late to fire. It's too late when you fire it.
It's too late.
No, but you need someone else anyway. So you need to bring in someone else. So you can just as well get rid of the guy.
Okay, I'm just going to start passing around. Maybe goes up this side and down the other. So there's a card, and there's just in case you're interested, there's a heatsink. We took it off so you can have a look. So we can pass it around. No, that is not plugged in. It is no use whatsoever. I'm sure someone's broken that one already, so don't worry too much if you drop it.
So if that was just an ordinary old SCSI card,
you wouldn't know, would you, necessarily? It's got NVIDIA written on it somewhere. Yeah. Okay, so this is the new hardware platform that we have just announced. Okay, this is a Medusa 2 card.
Is this a special one nobody else knows about?
No. This is one we announced last week.
Yeah.
Last week. So we've announced this.
Yeah.
This is a card that we've now announced. Okay. So we have switched architecture from one vendor to another. So we're using the NVIDIA Bluefield 3. To your point, it's irrelevant to customers, and we can switch it again, and no one cares because only our software runs on it. So that's the magic of it's completely irrelevant to those people. So there is a Bluefield. NVIDIA make the Bluefield DPU. There's a selection of different SKUs of that card. This is our own version of that. So we take those components and we build our own card because we needed some extra things that is not in the Bluefield card. The Bluefield card itself is exceptionally good at doing all the networking type stuff and security. It has a couple of things missing if you want to do storage as well. So we've made some subtle differences to that card. A lot of it is generic Bluefield stuff, cores, etc. We put a chunk more memory on it because we want to run some extra stuff, so we up the memory, so there's more memory than you can get on the standard Bluefield. We add in some back-end drive connectors, which when the card comes round, they sit up here. So this is how we physically connect to the SSDs in the back of the servers, either 16 directly connected or up to 24 with an expander of some kind. We have that physical security chip on there. So there's a question over here.
Yeah, is there any component there that is specific to Nebulon?
We don't.
The card is yours, it's fine. Is there a chip or anything on there?
There's nothing that's custom. These are components we purchase in the standard supply chain. It's a packaging that's magic as opposed to
that's
the
fine.
product.
Yeah.
And software.
And the software is the most important thing, yeah. The hardware guys hate me for saying that, but that's the reality of it, the software stack. We do this because we have to. There's a battery. We put a battery on here. If you're in the storage world, you need battery backup. So if the server has a power failure or resets, you need the card to stay running because we're having cache in there. That's not standard on a thing. Also means that one of the uniques we have compared to HCI type platforms is we continue to run even when the server isn't running. So if you think about, vSAN is a great example. If I patch and reboot that server, I take vSAN offline while I'm rebooting it. If you patch and reboot VMware when you're running on Nebulon, you do not take the storage offline. You patch in the operating system, you're rebooting that server, the card with all the data services stays running and it will ignore reboot commands. And the battery will allow us to, even when the server does a hardware PCI reset, disconnects power, we ignore it and carry on. Okay, so there's a few changes
Just a quick thing, how often do you actually have to reboot the SPU?
Assembled in the US.
You don't have to. It gets rebooted if the server gets shut down, but you don't have to reboot the SPU.
But if you update, say, the firmware on it, things like that?
So the firmware is very infrequently updated, and it gets staged, and it only ever gets applied when there's a reboot of the physical card, should it need to be due. So NebOS is an application running on the card. So we can restart NebOS virtually instantly. So we're all in user space, and that's the thing we have. So it's just a hardened Linux long-time runtime kernel that flows in there. So it doesn't need patching at all very often. The key thing is our bit and all the stuff we're doing, which is constantly new features, is a process restart, hence very, very quick, which is why we can update it live. So we can essentially reboot the Nebulon components without any interruption to the server itself.
The actual card assembled in the US, will that continue?
For the near term, yes. That's going to be a volume-dependent discussion. So as volumes get into 10,000 plus, there are other options that we would probably take advantage of to save folks money.
Then the US government would like to see you continue to assemble it in the US. There are incentives in that way.
I'm not finding any incentives in
Maybe ask for some.
Question for the questioner. Why does it matter?
Why does it matter? Because I think, like most countries, they would like to see some of this activity increase in their own territories for all sorts of different reasons. I don't know.
Yeah, it's a true statement.
I'm sure the issue with what's going on with code, if you look at it, maybe we'll see.
I guess the card got there. It's got "Made in the USA" written on it, hasn't it, in big letters? I noticed. So it's got all this stuff on it, and it has these network ports on the back, and these are essentially the Bluefield 3 network ports. ConnectX-7, so that is available to the host to use as well. So this is a great conversation at the start. We can replace the RAID card. We can replace a high-speed, high-performance offload smart NIC, and we can replace two M2 boot drives with this single card. Okay, so those ports are passed through, two high-speed networking ports are passed through to the host itself.
Do you recycle the ones you replace?
Well, the customer owns those.
Well, and we
probably under the Wii initiative, we probably have to, don't we? But I don't know that stuff with the vendor.
We rework them for sure.
There we go.
Something off topic, why Medusa? I mean, according to Greek mythology, it's not really the best thing.
Oh,
there's the marketing person in the room, so let's ask him.
So Nebulon, it's really a takeoff on Nebula because there's 20 copywritten companies already named that. That is a cloud in space. And the Medusa Nebula is what the card was named after. Medusa 1 was our first card, and we really just use that internally. What we found is when we talk about stuff with our customers and we talk project names, people kind of get attached to it. So we just thought, look, we'll just put it out there and have some fun with it. So.
Can I get one with stakes on?
Sorry?
Just don't look at it.
That's right. Make a great T-shirt.
Okay, so I think that's it really about the hardware card that will go around from that point of view. So this is the new card we've announced. And then the sneak peek that Craig has decided to tell anyone, which we're not supposed to talk about, is the 2i. So this is like a sister card of this one. So this is not the next one after this one, it's a sister card to this one. So this is something that no one knows about. You can see this one, the PCB isn't real. It doesn't actually exist yet. Yes, yeah, it's already there, I know. Craig was aware that that would happen. You'll also see that this card looks slightly different from that one, depending this one's got less ports on the back of it. So this is another card we are looking to produce. I'll pass this one around. The key difference is physically smaller. It's a lot smaller, and you can just about see this one has onboard storage. So I no longer need SSDs inside a server. Okay, so we have taken the standard reducer card, we've made it half-length card, we put onboard storage to it. If you get into technical details, it's about half the CPU, half the cores, half the memory. So it's cost optimized as well. Think about edge use cases. Okay, first of all, the servers are really small, so you want a half-size card. Secondly, those servers have very limited or very difficult SSD storage. Some of those SSDs can't be accessed very easily, some are internally. I can't get very many in them. Okay?
Did I miss something? How does this card connect with the other one? Was it the sister card?
It doesn't connect to the
other one. So this is a completely different card. So you buy this one or the other one.
Oh, or the other one.
Yeah, this is more for edge use cases.
Oh, I see. I thought sister as in
sister as in a parallel card for not a replacement, not a next generation. Yeah. A different SKU.
Understood. Yeah. No, I thought they sat together and they.
No, not a daughter card, a sister card. No. It's lost in translation. My mistake.
Okay.
They're not blood related.
So that it's still sort of fairly well up the chain of edge, isn't it?
Well, no, because if I take an edge server, okay, I have to buy a RAID card, I have to buy a network card, and I have to buy 2 M2s. Okay, I can just buy this one card.
Yeah.
Okay, so it's replacing a lot of components with this card. Okay, it's also, you may not get the capacity you need in some of those edge servers. They're very small, and I can put a lot of about 32 terabytes on one of these, should I so wish, if the edge case, maybe edge AI or something. It's designed really for those cost-optimized customers where edge deployment, small, low-cost, full functionality. When you get to edge, we have a lot of, a great example being things like retail. Think of retail store. I've got a couple of servers in every store. Okay, comes back to the point I think somebody made earlier on about running a CPU high and low and that type of stuff and thermals and stuff. We get a lot of interest in retail about noise because they're sitting in someone's office. So if you can reduce CPU consumption on a server, you can run that server at a lower CPU rate. You can turn the fans down and it doesn't make as much noise, which means it's less likely that someone's going to turn it off because it's noisy.
I think about even smaller edge use cases and do it away with the server altogether. Because that looks like a very good hyper-converged system.
Right now, this is designed
He's asking for an answer, by the way.
Make your software run on a laptop and stick a laptop in.
Yeah. Okay.
You can't plug an SSD in.
Yes.
As well as.
No, it has four of these M2s in it.
Okay, so you can plug the external SSD.
No, it just uses these. It's designed as.
Thank you. So I noticed that one's got an 8-pin power connector, so that's obviously running 150 watts ish.
No, this one is fractional.
No, but this one has the 8-pin, so I'm assuming that's 150 plus watts.
No, it's about 65, 70.
Okay. Yeah. And that one is what?
A lot less.
30, 40 watts.
I don't know the numbers. We haven't benchmarked it yet. So this card has a power connector, as you've well seen on it. The current card runs well over 75 watts, so we use that power connector. We are just going through the testing now to see whether we need to use that or not. We're just under 75 at the moment.
It may be worth having, say, a version that is capped at 60 watts.
Yeah.
So it doesn't need it for those servers.
Well, that's where we go through, because we can do that in software.
Yeah.
So you can have it, if you plug it in, you can maybe go faster, but actually, we haven't found yet that it runs over 75 yet in testing, so we're just going through that process, but yeah, well.
You actually sell one special cheap one, clocked down to half speed, and then they buy the more expensive one, then you just switch the software.
Our simple approach for marketing is you buy that, you get everything, so it's nice and easy for me. Licensing, customers do like that, and I like it. when I'm talking to customers, you buy it and that's it. We don't have to worry about the features.
And again, the commercial model, so they buy the card, and then you also have the cloud management service. Okay. So do they have to keep paying over time for that?
Yes, so there's a physical acquisition cost of this, and to be honest, what we find with most customers, it's cost neutral, because I'm replacing stuff and I'm putting this in. It's about the same. Okay, so it's virtually irrelevant to most customers. And then there is a software subscription per server. So if I had 1 or 2 in, it's irrelevant. The software subscription is per server, and you have a 1, 3, or 5 year. So it's a SaaS model per server.
That's physical server.
Per physical server, correct.
And you'd say presumably that the management is simpler, so you're saving on management overhead.
Saving on management overhead, but you're not buying necessarily like a vSAN or HCI type licenses either. No. Now, how much does a vSAN license cost per server? Well, it's quite substantial from that point of view.
Is this still a Bluefield-based card?
Yes, this one is Bluefield, yes.
Yeah.
So it's just, in a nutshell, it's just got less cores, less memory, and we've taken away some of the physical stuff like SSD connecting on the back of it. But we still cram the battery in there and the unique stuff we had.
So you see there you've got 4
Yeah,
ports
I told you it's a prototype, didn't I?
So yeah, just wondering.
That's changed.
Yeah. What would be the natural sort of port density on something?
Okay, so this card is one we're launching. Shortly afterwards, there'll be another SKU with 4 ports on the back. So the Bluefield's capable of 400 gig. This one is 200 gig. It's capable of 400, but we've only accessible 200. There'll be a SKU that has 4 ports that allows us to go to 400 gig on that side. On this card, there'll be variations of this. The reason why 4 ports is most likely is because we can, I think 2 servers edge use case. I can use 2 ports for Nebulon and directly connect them. So I can run those ports at a very, very high throughput without buying networking infrastructure. I don't have a 50, 25, 50, 100 gig switch on the edge side, but I'd love to have that high-speed connectivity. Then the other 2 ports, we can run at a low speed off to their network for host access. So that's why.
So essentially you're just directly connecting multiple Nebulon hosts together to run as a fabric.
For our own backend, nothing to do with the host, that's purely for Nebulon traffic, for those small edge locations. In most data centers, they'll go to the top of rack switch.
What sparked off the development of the 2 icons?
It was driven by edge use cases.
Yeah. Who from? Because you could have gone to talk to edge people, but I'm guessing potential OEMs came up to you and said.
Yes, so some of it's through the 4 OEMs we've already talked about. Some of it is to do with, we haven't got our current generation card, it's even bigger than this one. So it's like, well, that's not going in the edge, because it looks like a GPU, our first generation card. It's a double width one. They're very, very large by comparison. So too big for edge, can't use. Physically, doesn't fit in our edge line or for certain models of service. So they wanted a much smaller one, so we love this one. Then people saying, actually, we don't need all that performance. Okay, cost is king at edge, so can you make one that's much, much cheaper? So we stripped out everything, half the cores, half the memory, removed everything, and then made it even smaller so it fit in pretty much any server, even those really unique ones from that side of things. So it's heavily cost optimized was the driving force, and then can you package it to fit in some of those really small servers? And some of those servers are just horrible to put SSDs in because they're all in funny places the way they built them.
Thinking about using this in non-rack mount edge servers?
Yes. Really unusual form factors where you can't possibly get, this is a behemoth to some of those edge servers. This card is gigantic and doesn't physically fit in some of those ones. But the key advantage here, if you're thinking of a hardware qualification, okay, there's no cabling, there's no SSDs, there's nothing. You just literally push this card in the server and it's done. Okay? Whereas in the normal world, I'm buying this card and I have to put cables to the SSD, connect the drive cages up, that type of approach. Okay? This small one just plugs in and works. Incredibly easy. When you start talking about those retrofit, that's perfect for that. It pushes and works from that side of things.
In terms of the go-to-market, which we heard mentioned at the beginning, that there's zero-day stuff, there's ransomware stuff, these 2 cards. You came out of stealth about 3 years ago, and ever since you've been trying to build up the channel in Europe, etc. Is this going to have a big effect on that, you think?
Do you want to take that one?
I can do. I think Phil lives it. I think he's seen a lot of the demand, but again, bringing the convergence of all these services on these cards and the 2i with its form factor at the edge, part of how we go to market, we stand together with the server reps from these large companies. And a server rep who's trying to digest a portfolio of products in their own company, they see that 2i card and the light goes on. And they just get it by looking at it. And that is half of, building the business out here, is getting those server reps, to see and find that swim lane to then turn around and move.
Got something different to actually push. Yeah.
Yes, for sure.
It gives the server OEMs remote management of edge servers.
100%. Yeah. So they have not just inventory, but they better understand timing for any kind of replenishment. So it's very advantageous for them. A lot of times, all they know is the disti they sold to. So this keeps them informed.
Are you thinking of a solution? I mean, there are many customers that are using, hundreds of servers.
Yes.
And they don't want to have a cost of a card on each one. Are you thinking of a device that you could have maybe on the leading server that would provide the services to the others within the infrastructure?
So we just start on the first thing. So this is cost neutral or less.
Yeah, I was just going to say, all servers have a storage card for the most part today, and that hasn't changed over the years, whether you're using external storage and internal storage with an HBA RAID card. So for the most part, it's just part of a BOM, and once that BOM is set for a project, just turn the crank for your servers. Anything different from that is a little, I think if you follow that RAID card motion, that's what people know. That's simple for folks. So,
are you suggesting that these edge servers could have no local storage apart from what's on the reducer 2i card?
Correct.
That's a hyperconverged system. For God's sake.
I'm going to write this one down.
You're in trouble now, he's put his glasses back on.
But could then, given the increasing or decreasing size and performance of many of these sort of small edge servers, can one of those cards then start managing multiple of those, if they're, a range of machine tools, for example, one could handle half a dozen.
So this is a component inside that server, and then that server manages the other stuff. So we're a component player in that. We're not a standalone device. We go inside that server. If you're talking, we have people in manufacturing, for example, buy a couple of servers, a couple of these cards in it, gives them remote management, incredible security. Think about recovery time. You're running a manufacturing plant, it costs you £1 million a day if it's offline, ransomware attack, click a button at HQ, roll the plant back 10 minutes, back up and running again. The value is huge at that area. Yeah. And for something that's the same cost as an existing RAID card, why would you not do it at that scale? And all the benefits of centralized management, more security, ease of recovery.
Yeah. Why would insurance companies drive the adoption of something like this? Because cyber insurance must be...
It's going to the roof to the point where it's not allowed in some
places. And countries are suffering from spending a fortune on coordinating reputation. Why don't the mutations
I'm with you on that, 100%.
Not this necessarily, but just a general minimum level of security.
I think that's exactly the kinds of discussions we ought to be having with the insurers out there to make the business case for them.
Have you been thinking about having a reducer 2i fitted in Intel NUC servers?
I think it's kind of down to form factor because I'm not sure how tight those are. I think we've been, we're trying to make it a ubiquitous one-use server solution. there's a couple of edge servers we've dealt with that are 1U, but they're kind of a funky form factor. It's worked in the ones we've tried. I think it's a function of taking a look, and because anything it'll fit in, we're good to go. The thing we sometimes forget to do in our industry is give a customer the recipe. What do I do with this? How do we use it? For us, it's edge. It's for companies that are transforming their traditional 3-tier data center into more of a cloud data center. We're also working on recipes for AI-based infrastructure. We develop the blueprints, we share them with customers so that they understand how to do it. And we've talked a lot about edge here, but there are some burgeoning opportunities for AI infrastructure around helping checkpointing in terms of the speed of that. Today can be a very long and difficult process.